box plots or box and whisker plots are just an easy way to visualize the spread of data. So like specifically the minimum value, lower quartile range, the median, the upper quartile range for Q3, and the maximum value. All those things are known as the 5-number summary. It's like the 5 key things you need to measure the spread of data and to make a nice box plot. So here's an example, right? Just from this box plot right here, box and whisker plot, you can see that, oh, the minimum's right there. There's the maximum. This right here is Q3. That's how you draw wherever Q3 is. You draw a little line there. There's the median, the middle right there, and there's Q1. So right, lower quartile, upper quartile. This is a 75th percentile. This is a 25th percentile. This is a 50th percentile. The 0 percentile, the 100th percentile. It's just a real quick way to find out those values, or if you have those values, to make a nice visualization for it. And then eventually we could talk about, is it positively skewed, negative skewed, or symmetric? Kind of like what we're gonna do right now. So here's a good example of a bar graph that's symmetric, and then if you relate it to a box and whisker graph, you get this right there. Again, the key things to look at the tails. In this case, it's in the middle, so symmetric. Here's the positively skewed one, right there. Right, again, you want to look at the tail. That's the dead giveaway. If it's positive or negative. And again, a lot of people get this mixed up. They think this is negative because it looks like it's really negative. That's not the point of it. The idea is, yeah, most people are negative, but there's a few people up here that's bringing the score up, so it's higher than it should be. That's why it's called positive skewed, right? It's skewed positive. It should be low, but it's skewed positive. Likewise, when it's negatively skewed, right? Like, man, people did really well on this test, but a few losers brought the score down. That's why it's negatively skewed. Because it should be a high score, but it's lower than it. The average is much lower than it should be because a few people brought the score down. So it's positive, negative, and symmetric. Let's look at a quick example right here. So they want you to construct a 5-number summary for this data set right there. So first thing I do is set it in range. Again, I'm not going to waste your time by me putting it in range. I have it done right here. So you can see already the minimum value is 2. The maximum value is 9. Now there's 16 things, so if I wanted to find the median right here, it fell between these two numbers. So take the average of them, and it's 5. And then if I want to find Q1, lower quartile, remember that's the median, so I got to go to all these numbers, including the 5. Find the middle, which is these two. Take average of that, so 2.5. Same thing for the upper quartile. Look at all these numbers. Look at the middle, so 6. My Q3 upper quartile is 6. Now if I want to draw it, you just draw that stuff. Draw the min with a little point. Draw the max with the point. Draw the lower quartile with the line, Q1 with the line at 2.5. Draw the upper quartile with the line at 6. Draw the median at 5. And you have this little thing right there. And by the way, this is the IQR. This box right here is the IQR, right? Q3 and Q1. And if you want to find the IQR, just do Q3 minus Q1, or 3.5. If I want the range, right, max minus min, so 9 minus 2, and I get 7. So that's a quick example of how to use it. Let's move on to the next topic, outliers. So outliers you probably won't see in the IB test, but there's a good chance you can use it on your exploration. So outliers is a study of numbers that fall outside the normal data sets, that are too high or too low. There's actually a formula for it, which is not given to you on your formula sheet, which is why they don't really ask for it. I've never seen it on IB tests. But again, good reference for your exploration if you need it. And it's actually not bad of a formula. It's just the nearest quartile plus or minus 1.5 the IQR. That's all it is. So either Q3 or Q1. For the upper boundary, it's Q3. And then since it's the upper boundary, you're going to add 1.5 times the IQR. Right, so that's the upper boundary for, if anything falls over that, like let's say, let me draw a little thing right here. If anything falls past this Q3 plus 1.5 times the IQR, then that's an outlier. That's an outlier that's too big. And on the other side, if you have this boundary right here, which is like Q1 minus 1.5 times the IQR, anything falls below that, then it's an outlier on the other side, too small. So that's the way outliers work. Let's look at a quick example. So right, the test have the following data set. All these numbers, They want you to find that there's an outlier. Well, first thing you gotta do is find the number summary, the min, the max, and median. So they did it right here, right? They rearranged it. You got your median halfway between, so 8. They found the lower quartile, right? So they went to all these and then found the middle of that, which was 6 and 7, so 6.5. They found the upper quartile, right? So all those numbers found the middle, so 10. And then with that information, they found the IQR. Q3 minus Q1, 3.5. So the IQR of this data set is 3.5. Now if you want to see if anything's an outlier, you just got to test it. Now there's a couple possibilities, right? 1 might be too small, 16 might be too big. So let's test it. Let's use our formula. So you got to find the boundary. So upper boundary, upper quartile, which we found out was 10, plus 1.5 times the IQR, which we figured out was 3.5. And you get 15.12. So now remember, if anything's past that, it's an outlier. And look at 16. Too big. 16's an outlier. If you look at the lower boundary, it's the same idea. It's the lower quartile, which we found out was 6.5. We subtract off 1.5 times IQR, which we found out was 3.5. And if you do that, you get 1.25. Now again, if anything falls below that, it's an outlier. And again, we have one. One's less than 1.5. So we have 2 outliers in this data set. 16's too big, 1's too small. If you want to show that in your box and whisker plot, the way you do it is you make them little stars. So you have your normal, you take out the outliers, right? That's not including your data anymore. But you make them little stars to let you know, oh well, those are outliers. Also, they're kind of stylish. So there you go. Let's finish off this lesson by doing a couple quick examples. So here's our first one. A set of data has a lower quartile of 31.5, a median of 37, and an upper quartile of 43.5. So the first question is, find the interquartile range, right? So IQR. IQR is just Q3 minus Q1, or upper quartile minus lower quartile, which they gave us. So 43.5 minus 31.5, also known as 12. That's my IQR. For B, they want me to calculate the boundaries. So remember, I'm just using those formulas. It's very simple. If you want the upper boundary, you just do Q3 plus, because it's on the top half, 1.5 times IQR. If you want the lower boundary, it's just the lower half, and then you got to subtract off 1.5 times IQR. So in that case, this is going to be 43.5 plus 1.5 times 12. So that's going to be 9 plus 4.5, so 52.5. On this side, that's going to be 31.5 minus 1.5 times 12. So again, that's going to be 9 times, let's see, 9. Whoa. That should be 18. Sorry. 1 times 1.5, so 12 plus 6, 18. That's embarrassing. So 61.5. And over here, same idea, it should be 18. So that's going to be 13.5. So those are your boundaries. Right? Anything above this is an outlier. Anything below this is an outlier. Then let's look at C. Do you want to know which one of these will be an outlier? Well, 22 falls within the range. 13, that one's just below. So 13 will be an outlier. 13.2, I should say. 60 is good. 65 is too big. So that's like calculating and find outliers. We're going to do one more example. The last example deals with how do you do with frequency. So you know how we do this? With our calculator. It's too much work otherwise. So you bring out your calculator. I'll put it over here. We're going to enter in our data. So write the stat edit. There we go. Again, you want to clear it. You don't want to put the delete because then you just lose it and then you have to get it back. It's actually not that hard to get it back, but people freak out. Anyway, just enter in your data. It's not that much this time, so I'll just show it. 40. There you go. So, and then L2 will be my frequency. So there's only 1 33 number of volts. There's 5 34 number of volts. 7 13 12 8. No, 39 volts. And then 1 40 volt. So all our data is inputted for the number of volts in boxes. So next we're going to do is find the 5-number summary. So again, I'm just going to get out. Hit stat, calculate, one variable stats, right? We only ever use one variable stats in this class. I do have a frequency list this time, so I gotta put my L2. Hit enter, hit calculate. And again, there's mean, there's standard deviation, stuff I haven't talked about yet. I just want the 5-number summary, so I'm gonna scroll down to the very bottom. And there is my 5-number summary, right? All right there. All right there. If it let me highlight it, it would be nice. So there you go. You want to find the range? Well, I actually don't need the, well, I could use it, right? The range is the max minus min, which is just be 40 minus 30, R7. The IQR, I need my calculator back. So it's going to be Q3 minus Q1, so 37 minus 32, 5, sorry. Let's do the math in my head. 37 minus 35, because this was Q3 and Q1, so just 2. So it's very bunched together. Most of the data falls within 2 of each other. Draw a box plot. Now I can do this by hand, by using my 5-number summary, doing all that. You can also use your calculator though. So if you want to use your calculator to do this, it's easy enough to do by hand. But you go to stat plot, second Y, so you get stat plot. Turn one of them on, and then you want to highlight the box and whisker plot. That there's actually 2. One has outliers, one doesn't have outliers. We're actually not sure if it has outliers yet, but we'll click this one first. Well, let's click the one with outliers. We're not sure. And then I go L1. Scroll down. I have a frequency, L2. Right, so notice I change L2. Pick any color you want if you're so inclined. Hit graph. And right now you don't see a thing because our window's not fixed yet. So the easiest way to fix your window is put zoom and then go to stat, zoom 9. There's my box and whisker plot. Are there any outliers? Well, now I got to figure out the mathematics. My guess would be no, because it looks like it's all kind of bunched together. But if I want to figure out what the outliers are, I use the formulas, which is Q3 plus 1.5 times IQR, Q1 minus 1.5 times IQR. In this case, that would be 37, I'm looking down there, plus 1.5 times 2, so that's just 3, so this is 40. So that's a boundary, so anything that goes past it is an outlier. 40 is 40, so it's not an outlier. Q1 is 35, minus 1.5 times IQR, which is 2, so 35 minus 3, which is 32. So again, anything that goes below that is an outlier. I don't see it again, so there's no outliers. And that's how you find outliers, and that's how you deal with frequencies. That's it for the lesson.